To determine whether these two variances, the variance for women and the variance for men, can be considered different, we're going to use a statistical test that relies on the F distribution. The F distribution is essentially developed from a comparison of variances. An example of the F distribution and what it looks like is given in figure 9.8 on page 291. As that figure shows, the F distribution is not a symmetric distribution as the T distribution is, but it is rather asymmetrical, being skewed to the right. How can we use the F distribution to determine whether the two variances we're dealing with here are actually different from one another? The way we do that is to calculate an F statistic. And the F statistic is equal to one variance, in this case I'll take the larger, divided by the other variance, the smaller. And the F value I get from that division is 11.51. What is the probability of that F statistic? To find the probability, I use the fdist function. The fdist function takes three arguments: the F value itself, degrees of freedom in the first variance, and degrees of freedom in the second variance. In this case, the first variance is the variance for women. Its degrees of freedom are equal to essentially 34 minus 1. And the degrees of freedom for the second group is essentially the same. When I hit enter, I discover that the probability of an F as large as 11.5 is a very small number indeed. On the basis of that probability, I would conclude that the null hypothesis in this case, the implicit null hypothesis that the variances for men and women are equal, or that they are not different from one another, cannot be supported by the data, and I would conclude that the variances are different. I could have calculated this F statistic not by dividing the larger by the smaller as I did here, but let's calculate the F again and divide the smaller by the larger. In this case I get 0.0868 as my F statistic. What's the probability of that 0.08? I'm again going to use the equal fdist function, the 0.0868 as x, or the F value, degrees of freedom equal to 34 minus 1 in the first or in the numerator, and degrees of freedom equal to 34 minus 1 in the denominator. And I see that the probability is virtually 1, but the actual probability is not fdist, f14, f6 minus 1, f6 minus 1, but 1 minus that value. And in this case it is 0, but if I change this to scientific notation, format cells in scientific notation, it comes out to be exactly the same as the probability of the F statistic calculated with the F value of 11.5, where I divided the larger by the smaller. So the bottom line on this is that if you divide the larger variance by the smaller variance to calculate the F, the probability is given by fdist itself, as is shown here. But if the smaller variance is divided by the larger variance, the probability of that result is given by 1 minus fdist, as shown here.